The question says para-dichlorobenzene has higher melting point and solubility than those of ortho and meta-isomers. Ortho and meta-isomers means ortho-dichlorobenzene and meta-dichlorobenzene. There are 2 points which we have to explain. Why para-dichlorobenzene has higher melting point, and second, why it has higher solubility. So first of all, we can draw the structure. Okay, we have a dichlorobenzene there, but one Cl will be at the para position. Okay, this is para. Next we have ortho is there. Next we have ortho. Okay, ortho is there, Cl, and in this case Cl is there. Okay, next we have meta is there, meta. Okay, Cl is there, this is Cl is there. So this is ortho and this is meta is there. Okay, and we have to justify why it has higher melting point. First we discuss about the melting point. Okay, so you can see this Cl is an atom, and atoms are in a spherical in size. So let's say this is a sphere and this is also a sphere is there. Okay, from here if we cut, so this compound can be cut in equal parts, this part and this part. This is also cutting into 2 equal parts here also. So symmetry will be there, 2 equal parts. It can be divided into 2 equal parts. So it has a symmetry. Symmetry is there. Symmetry. Okay, it has symmetry there. In this case, you cannot cut whether if you are cutting like this also equal parts are not there. If you are cutting like this, equal parts are not there. Okay, here also if you are cutting like this, equal parts are not there, because this is Cl is coming, this side we do not have Cl. If you are cutting like this, then Cl will be this side, and this side we do not have Cl. So these 2 compounds do not have symmetry. It has symmetry, and always keep in mind, if the symmetry is there, any compound is there which has symmetry will be having higher stability. Higher stability is there. So in this case, lattice enthalpy will be very high. Okay, strong lattice will be there, and when strong lattice is there, so melting point will also be very higher. Okay, so with lattice of this compound is very strong, then melting point will be higher. And one more thing, when we are talking about solubility, so keep in mind, we have dipole moment plays a significant role, and based on that we can explain the solubility also. If you find the dipole moment, you can see in this case dipole moment is 0. Complete cancellation is there. Otherwise, we have learned, dipole moment is inversely proportional to bond angle. So in this case bond angle is what, 180 degree. In this case bond angle is what, 60 degree. And in this case bond angle is what, 120 degrees there. 120 degrees there. Okay. So in general, this one is supposed to have a higher bond angle. Okay, so it has polarity. In this case, dipole moment will not be equal to 0. In this case, dipole moment will also not be equal to 0. But in this case, we are getting dipole moment 0. So it is non-polar by nature, and they are having the polarity. It is also having the polarity. Okay. It means since it is non-polar by nature, so if we talk about non-polar solvent, so this compound will be more soluble in non-polar solvent. Okay, in terms of non-polar, you cannot talk about adding to the water. Okay, because it is non-polar by nature. They can dissolve to some extent because some partial polarity is there. Okay, but this para-dichlorobenzene is more soluble in non-polar solvent, because for this compound dipole moment is 0. Okay, so both the points we discussed, because it has strong lattice due to the symmetry, has higher melting point. Second point, it is non-polar by nature, because dipole moment is 0. That's why it is more soluble in non-polar solvent like carbon tetrachloride, acetone is there. Okay, ether is there, and we have CaCl3 is there. So in these solvents it is highly soluble. If you like this video, please share and subscribe to the channel.